Hi, Jiwon. What day did you assign for me to give a presentation? Jiwon, you're on mute. Do you hear me? Hello, Jiwon. Jiwon, are you there?
Hi, Chris. Can you hear me?
Hi, good morning.
Hey, thanks for tuning in. I know it's quite late for you there. Uh,
Well, we
thanks for
just
tuning.
had daylight savings time,
Okay.
so that kicks it back an hour, so not quite as late
All right.
as
All right.
it
That's
was a week ago.
okay. Yeah. Is there anyone else
I s-
joining from your team?
Hmm, no,
All
no.
right. Okay. We'll give a few more minutes. Yeah. Jiwon is Song joining us today.
Say again?
No, I was asking Jiwon, one of our coordinators here, whether Song will be joining us. Yeah.
You can kick out my note taker. I don't know why it shows up. Sorry, kick it out.
Yeah. Yeah. So do you have like a AI note taker enabled in your
I signed up
uh,
to this thing once and now it's sort of like seems to have a mind of its own and pops up when I don't expect it and then doesn't join when I was hoping it would.
mhm.
So it's kind of like hell. And how the computer that was it on 2001
Yeah, I just
season.
watched that movie last night. This
Did
is a
you?
very weird coincidence. Yeah, yeah.
Wow, it's a
Somebody
classic.
was talking about film theory, and I consider myself a pretty sci-fi oriented person, and I realized I never really saw 2001. I saw 2010,
Ah,
but that's when I was younger, and I liked the actor. The same actor that was in Jaws was in 2010, which is a continuation of the story. And now that I've seen 2001, it probably would have been a good idea to see that before 2010 because there's a lot of setup and context that they
oh,
give you in 2001.
okay.
the monolith and everything. So yeah, but I'm just saying, I just watched it last night. It's on HBO Max.
Uh-huh.
Long movie, like things are drawn out. I
Mm-hmm.
think it came from a time, because it's a 1969 movie, and I think it came back out of a time where the director and the filmmaker want you to make sure you're catching every detail. So they'll go through a whole scene very slowly.
Okay, I think we've got people tuning in already. Shall we get started? Yeah. Hey, so.
Hi, everyone.
Hello. Yeah. Okay. I think people are coming in. Just give another minute and then we'll get started. Yeah.
So your background is clearly fake, Chris, because it's not that
What do you
right now.
mean? This is my beautiful thing. I
You
can
have
throw
like
a virtual ball at the virtual wall back there. What are you talking
yeah,
about?
looks like you have sea water view, waterfront view there.
Yeah, I'm in Florida, so could be true. Could be true.
Oh, you are in Florida?
I am in Florida. Yes,
I thought you worked for J&J. They're
I
just all
do.
over the place.
We have people all over the place:
Oh, okay.
Virginia, Vermont, West Coast, but quite a few people in the EPI department are in New Jersey. The headquarters is in New Brunswick, New Jersey. So, but I'm in Florida. Never looking back. It was like 73 degrees today. Not bad.
Wow.
Okay, cool. Let's just get us started then. I think I've got quite a fair bit of people in already. Okay, so we've got Chris here with us. Chris is from the Odyssey Atlas team, and he'll be here today sharing with us about how we can use Odyssey for vocab search, concept set building, cohort definition, and characterization, as well as share with us the roadmap that's to come for Atlas as we go forward. Yeah, so over to Chris. Thanks.
Well, thank you very much. So yes, my name's Chris Knoll. I work for Johnson & Johnson, but since the inception of like Atlas and some of the prior tools, which was around 2014, 2015, I've been serving as sort of a tech lead on those projects. Today I'll be talking about using Atlas, specifically vocabulary searching, concept sets, cohort definition, and characterization. I was kind of requested to do a deep dive in Atlas, but that would take many days to go through everything. Like we've done week-long classes on different things, trying to cover all the elements. But instead, I'm going to show you kind of like how all these different elements come together to facilitate study creation and study design, and also some data exploration. And hopefully after this meeting, I'll send the slides out. You can like follow some of the links and explore some of the studies that are out there and import some of those cohort definitions into your own environment. And you can kind of take a look and see what it can do for you. By the way, I have two screens here, so that's good. I can see hand raises and stuff like that. So if you have any questions or anything like that, go ahead and raise your hand, and I'll do my best to answer any questions that come up. So what I plan to talk about on this is just some general key concepts, just to kind of give you guys some concepts and context about, hopefully, if you know some of these key concepts, it'll make some of the thing earlier. I might poll the group to ask if everything is understood there, so that I know what I can gloss over and maybe some things I should go into more detail. I'll talk about the Odyssey study that we're going to just kind of use as a backdrop at the presentation. I'll go through the Atlas features from data sources, vocabulary searches, cohort definition building, characterization, and incidence rates. And then, as was mentioned, we'll talk about what some of the future plans are, sort of a roadmap, but just the general idea of what we're going to be doing for 3.0 and then ultimately 4.0. So for key concepts, the first thing is just the OMOP common data model. This Atlas functions are built very much around the main concepts you'll find in the OMOP common data model, meaning their vocabulary, the notion of a concept relationship, concept ancestors, the domains of information in the data model, such as person, drug exposure, drug error, condition, etc. So that's what you should have in some familiarity. Just as a quick poll of the group, raise your hand if you know what the common data model is and maybe have an instance yourself of it. Anyone? Okay. Good. 2, 3. Okay, good. There was a V6 that kind of like stalled at launch. So the latest version of the CDM is 5.4, and that's what Atlas supports. The second element of a key concept is a nested idea of the vocabulary. So while the OMOP CDM defines what tables are in there, the OMOP vocabulary is specifically about how to code data. We call them concept IDs, but a concept ID could represent a procedure, a type of visit, a condition, a diagnosis. So there's tens of thousands of concepts that come from like different vocabularies out in the world, ICD-10 codes, ICD-9 codes, SNOMED, MEDRA, things like that. There's 2 flavors of concepts as well, standard and non-standard. If you can imagine a code, we're going to be talking about type 2 diabetes as an indication today. And so there's an ICD-9 code for diabetes, ICD-10 code for diabetes, and a SNOMED code for diabetes. We don't want to make people say when they're defining code lists, give me all the different codes for all the different coding systems. Instead, we instruct people to ETL their data into a standard coding format. And therefore, all of our tools, as long as they're coded to look for these standard concepts, will deliver an estimate of an effect estimate or something like that. The last element, and this is more of a broader term, is real-world evidence and observational data, which can be sourced from anything in the world, health records, claims data, survey, or any type of health record. And the task of ETLers, which stands for extract, transform, load, is to convert that source data format into the CDM format. Once you do that, you can pretty much use our tools to explore the data, create cohorts, etc. For this presentation real quick, I'll be talking about this study, estimating the risk of non-arteritic ischemic optic neuropathy, known as NAION, and diabetic retinopathy, DR progression, associated with semaglutide exposure in patients with diabetes mellitus. I have 2 links here. You can check it out later, but it's this actual study code that's in our project, and also the protocol, which is sort of a markdown document translated into HTML. So for the study, just they're estimating the risk of ophthalmic complications, specifically non-arteritic ischemic optic neuropathy, NAION, or diabetic retinopathy, DR worsening, with semaglutide compared to other GLP-1s and non-GLP-1s among diabetes patients. So there's 2 stated objectives in this. The first one is effectively a comparison. And the second sentence is talking about a self-controlled analysis. So they'll say to estimate the relative incidence rate of NAION and DR worsening associated with GLP-1 RAs and non-GLP-1 RAs, exposure compared with non-exposure. So when we talk about self-control studies, we're talking about the on-treatment versus on-treatment time to get an odds ratio. And when we talk about risk, we're talking about a Cox proportional hazard between one group and a comparator group. So this study has several cohorts for comparators, targets, and outcomes. And Odyssey
Lost? I lost sound?
Yeah, there's a bit of a freeze there.
Oops.
Let's give it a while to see if Chris comes back. Yeah. Okay, Chris has dropped off. I think he should be joining in again. Let's see. Well, while waiting for Chris, is there anything that the community wants to discuss? Maybe about the upcoming APAC symposium or any other areas you want, so?
You pointed me in song again. So
You're putting us on the spot.
Just to get some airtime, right? While waiting for Chris to come back. Yeah.
I'll be at the symposium this year, so I'm gonna wish I could see you, Mukesh, in Shanghai, right?
Mhm.
And Cynthia, are you coming or not? You
No, I won't.
you
I'll
know,
have.
you want go to Africa one?
Am I on mute? Let me see. Whoop.
No, we can hear you.
Oh, okay. Yeah, I'm going to the Africa one, and then I'm going to a wedding in India,
Ooh,
right around the time
nice.
of the China, I mean the symposium in China, so I won't be able to
Wow.
make it this year.
I heard that in India the wedding goes like a whole week. Is that right?
It's going to be 3 days,
3 days. Okay.
and then I'll stay an extra
Cool.
week to do some traveling around while I
Oh,
made
cool.
that trip.
Oh, where at?
Probably we'll go to let's say maybe Pune and Goa.
Oh yeah. You know what? I was in Pune for like 6 months when I was young.
Oh,
Yeah.
well, can you send me some recommendations of what to do?
Yeah, well, I was like fourth grade in elementary school,
Oh,
so
okay,
I have
okay.
I have no clue. But I've been there, so
Oh,
yeah,
okay.
great city.
How about you, Mukesh? Does anyone been to either of those places?
Personally, I've
Pune.
not been there to Pune, but I heard it's a nice place in terms of its sceneries and locations. Yeah.
Hmm.
Yeah.
It's the birthplace of Iyengar yoga.
Yoga. Oh,
Mm.
nice.
Iyengar, a kind of yoga,
Mm.
Oh, it's a kind of
type of
yoga.
yoga.
Oh,
Yeah. So I'm looking into whether to do like a couple of days at a yoga retreat.
Yep. Yep. Might be a nice way to spend time there. Yeah.
I've lived in India for like 5 years during
you
my
did?
childhood as well. So like
Really?
yeah.
Wow. Which part?
So like, but again, like ㍍Using, if you asked me anything about recommendations,
Recommendation.
that's
No.
like what 20, 30 years ago. I don't know anything. I was just dragged to India by my parents. So unfortunately, I don't have recommendations. But I hear Goa is great. That's for sure. Not sure about Pune, but yeah, I'm sure you'll have fun. But yeah, I hear depending on where you go, it might be dangerous for tourists, especially if you're traveling alone. I don't know if you're with or without somebody, but yeah, I would watch out for that, just in case.
Yeah. Thank you. Where in India did you live?
I was in
What?
Mumbai,
Yeah.
5 years.
Oh, that's where I'm flying in to.
Nice, yeah.
Yeah.
During elementary, yes, and then I came back
Okay.
here, and then I flew back out to UAE. Not I think, to UAE, Abu Dhabi. So I lived there for another like 3 years. So yeah, I've been to
Wow.
the less common places of the world and
But
lived
that
there.
makes you special, like India and UAE. That's something.
Why is that special? I
Because
didn't put
nobody
a
goes
choice on it.
there. But
Did
you
you
know,
did you pick up any Hindi? Since usually in the childhood years, your brain is like a sponge and you can pick up other languages.
Right. And one of the regrets I have not learning Arabic and Hindi.
Hindi.
But I still know when somebody's swearing at me, so that's the first thing you pick up when you're abroad, right? So I at least know that. So if anybody
Okay.
curses at me, I will curse them back. But other than that, just the normal salutations everybody knows and stuff like that. Yeah.
Guess what? I can sing the anthem of India because I remember.
Oh wow,
Yeah, the whole
that's
Ooh,
thing.
that's
Yeah.
better than myself. 6 months and you can
yeah.
sing the
That
anthem of India.
yeah, it was so
Wow.
catchy. So so when someone asks me if you do you have any like special tricks you can do, and I said, do you know India's anthem? I can sing that. That's what I said.
And you actually do that. Drinking drinking situations, they'll be funny, right? Are you doing Are you singing the first phrase, the second phrase, the whole thing, or
And
just the yeah? Go ahead.
yeah, I can sing the whole line.
Wow, wow,
But yeah, but
impressive.
nobody knows that, so it's kind of awkward when I start singing because nobody expected like that I really gonna sing it. So
I think it will be more awkward if somebody starts singing along with you when you're not in India. So yeah, I think it's fine for it to be awkward, right?
yeah,
Interesting.
yeah.
When is Odyssey India happening? So that we can send you an explicit invite.
It already happened. Their inaugural symposium happened, I think, 2 years ago or 1 year ago. I don't recall now. But yeah, maybe they'll end up hosting one of or Odyssey APAC symposiums.
Yeah. Are they on the
T-
list yet?
Not yet. TBD.
Damn.
What's after China? Which country comes after China for
Korea.
the APAC?
Korea.
Oh,
Next year's
oh.
Korea here in Yonsei. Yeah,
Oh, wow.
we're hosting.
About time, actually. It's Korea.
And then Japan. And then I don't think we have maybe Thailand. I don't know. Yeah.
Oh.
But again, yeah, I don't know what's gonna happen in an hour. So yeah, I don't know about in 3 years' time. So
There's a part of the Indian wedding called the Sangeet. Do you know it?
No.
So it's kind of like a more casual part of the activities, festivities, and oftentimes friends perform for the couple. And so some of my friends who are going to the wedding have volunteered us to do a Bollywood dance. So that's what I have to do.
Bollywood
That's
dance.
interesting. Yeah, that's so India-like, right? Bollywood is a figure of India, right?
Yeah, it is.
Interesting. Have you guys seen Bollywood movies? Like, I don't know if everybody's seen them. They do have this very unique feature where
and
suddenly
very
they start.
humorous.
They start.
Yeah.
Oh, he's back.
Hey guys, very sorry about
Chris.
that.
Hi, Chris.
Occasionally, like
Hey,
an
Chris.
antivirus or something kicks in, and everything has to freeze, and I lose all my network. It's terrible. I'm so sorry.
No
Let me
worries.
try
Glad to
to.
get you back.
So
Yeah.
I'll pick up. I'll kind of gloss over some of that. I was going to go into a little bit more detail of the study, but not important. Let's just think about the actual app. So let me go ahead. You should be able to see my screen.
Yes.
Okay. I can hear my laptop starting to whirl up again. Hopefully you aren't going to lose me again. It's weird. I heard you guys talking too, and it was like, okay. So everybody can hear me okay?
Yes.
Yes.
Okay. Okay. So the last thing I'll just say about the study that we're looking at is I'm not running it, but I will be creating the cohort definitions and exploring the vocabulary to show off the elements of it. So Atlas consists of a lot of functions, data source characterization that comes from an Achilles analysis, which I'll talk briefly about, vocabulary search, concept sets, cohort definition through phenotyping, characterization covers things like comorbidities, concomitant medication type of things, like characterization at a baseline, incidence rates, and patient profiles, which we'll see all this today. So on the topic of data sources, Atlas presents web-based reports from Achilles analyses. These two links will send you to the R package, or you can install it using the remotes command I show you here. Atlas reports will be dashboard, data density, person, and visit, and then CDM domain-specific reports. So let me just show you that one real quick. So this is one of the first things I always celebrated when I finished an ETL, where I ran Achilles and got these reports. When you are in Atlas, you can configure multiple CDMs. So I'm going to choose my sample CDM here. Take a look at the dashboard.
Can you
so
make
this is the summary.
dashboard a little bit bigger? Sorry, the
Sure
print is pretty small.
Yep. How's that?
Okay. Great.
Yep. So the dashboard gives you a count, what the name of the source is, a a breakdown of gender and what the age at first observation was in your database. So it's kind of just a little bit of summary overview of like what you see in your population, but this is an important one, cumulative observation. The observation period table is the table that really says when a person exists in the data. And what this is showing you is sort of a survival curve of time survived, where 100% of the people have at least 0 days. But as you get down to the 50%, you have 50% of the population having at least 1.5 years of follow-up in this data set. When you get down to the lower quartile, you have 3 years of continuous observation. So this is a nice little report that'll show you like what kind of longitudinal information you might have in your system, because this is showing you how much continuous observation that they have. And we do it, it's kind of like how many people in a given month have observation, like at least 1 day of observation in that year. So that's the dashboard that kind of just gives you an overview. Other reports is data density. This is also good to look at when you finish your ETL. It kind of tells you like how many records are in each one of your tables. So these are all the domain tables of the CDM, and it's kind of giving you how many records are found in a year by year or month and year basis. Person's a nice summary report because this graph right here was the one that was on the dashboard, but it gives us sort of the year of birth, gives you a breakdown of gender, race, and ethnicity. If you're capturing that, a lot of data sources don't capture that stuff, so this report can show you that. I guess I'll just talk briefly about one of the data sources here. Sorry, one of the domain-specific reports. So this is the condition tree map. Gives you a little a visualization showing you bigger boxes are more prevalent conditions and darker boxes are more records per person. So you can see in this one, essential hypertension is a pretty big box. There is sort of a grouping happening here. So this is under that vascular hypertensive disorders, whereas this one is under respiratory tract infection. So we have chest pain, this one headache, et cetera, but normally you'll be looking for searching for text. We're going to be looking at diabetes. So this is showing us all these different codes that we have with people counting against those codes for type 2 diabetes that matches this text diabetes. So it's actually type 2, type 1, pre-diabetes, things like that. So there's lots of codes with various types of prevalence in here for these conditions. So this is just interesting. There is a drill down report, so you can click on one of these guys. Let's say we just want type 2 here. This drill down report shows a graph of prevalence over time. So you can see that this kind of like looks like in this data to be accelerating over time. Just FYI, this is just a sample of the data. I think I sampled more about recent years than older years, so that's why it kind of looks like the stuff is higher. There's a prevalence by month. You can see this, but one thing to look for in these reports is if you see something related to like ICD-9 to ICD-10 cutover, so occasionally you'll see something that looks pretty stable and then have a significant drop off in 2016 time window. So that kind of gives you some information about maybe something's up with your ETL or something's coded that way. Or a new code is happening, and so there's just some kind of data capture. But you want to look at these type of charts to see if something's happening in your data. I'm not going to go through all the other domains because they're very similar. We do show prevalence by gender over time in this chart, but then some of the domains have more specific information, like what the inpatient setting was for some procedures, etc. So you can look at these charts on your own time just to see what they are, but I just wanted to call out, this is what you do with, this is known as database characterization. It's not any specific population except for the general population. And this is a great report to look at when you just want to evaluate a database for like, say, fitness of use or something like that. Any questions on data sources that you'd like me to just drill into, or everybody get the idea? Okay.
How do you actually get your data source or atlas on top of your data source? Is that complicated?
So it's not. When you run these analyses, it will output the results into a table, and then you basically build your atlas results schema around the Achilles results. And so
Oh.
as long as the Achilles tables are found in the same place as the result schema that Atlas wants and Web API wants, then it will read it and find those
I see.
tables.
Thank
Yep.
you.
And I might be able to
Any
like quickly.
tutorials?
What was that?
Sorry, I was just wondering if there are any tutorials for this specifically. Are they available online or?
Yes, I believe. Yeah, I believe if you go to the GitHub repo, we have vignettes set up on how to execute it. This Achilles is one of the very first like large-scale data analytic packages that came out. Pretty sure we did a pretty good job documenting it.
Okay.
But I would say there should be vignettes covering all those methods, and it just basically gives you the commands to run. But just to show you what this would look like, if I just quick over to my CDM sample database here, this is my CDM schema, so it has the CDM tables in it. Then I have my result schema, which is having my result schema in it. And you can see this is the Achilles underscore tables are the ones that the Achilles analysis will create for you. So you just run the script, it will create the results table for you. And then when you configure Atlas to point to this result schema for one of your CDMs, it will read from those tables to show you the reports. So not too difficult, but there is certainly some technical steps to it. So far, so good. All right.
Thank you so much.
Yeah, no problem. So that really showcases, though, everything that you saw in this screen was concepts. These are vocabulary concepts. There's a concept around this type 2 diabetes. In fact, here's the column, concept ID. So everything that you'll see in here has some ID associated. So the next set of demos is going to talk about, well, how do I find the concepts that I want to use in my study? So back to this. And stop that. Okay. So when we talk about vocabulary searching and concept set creation, vocabulary searching means that we're doing text searches and other type of navigation through the Atlas UI to see what concepts are there, searching by text, and then seeing the relationship between one concept and another concept. I talked about standard concepts and non-standard concepts. So there's a relationship between a non-standard concept and a standard concept. That relationship will tell you how you ETL'd your data. So if you find an ICD-10 code and you look at what the SNOMED code is for that ICD-10, that's basically telling you this ICD-10 maps over to that SNOMED. So vocabulary searching is all about understanding the dimensions of your vocabulary. And then concept sets are just simply code lists. So what we'll be able to do is create a list of concept IDs, put it into a little bucket, and then we can say all these codes we're considering type 2 diabetes. So if you find a record in the condition occurrence with one of these codes, we're calling that a diabetes occurrence. So that's the general idea of like vocabulary searching and concept sets. A concept set definition is a concept that is put into a list. You can specify if this is going to be an inclusion or an exclusion, and if the concept should incorporate its descendants. So I didn't go into this too much detail, but there is a hierarchy in a vocabulary. So you could say diabetes is above type 1 and type 2. And then underneath type 2, you might have various flavors of type 2 diabetes, like complications, with a complication, without a complication, that kind of thing. So there's a whole hierarchy that goes into it, and Atlas will show you, kind of like visualize that for you or show it to you in a sort of a layout. But when building the concept sets, you will say, these are the concepts I want as descendants, or these are just what I want to bring in with descendants. And then you can also say, I want to get rid of these other ones. So you can do things with drugs, for example, where I want everything of an ingredient and its descendants. So that's going to bring in all forms of a certain drug. That's a type of ingredient. But then you can say, I'd like to exclude all the injectable forms of that. So you can say, bring in all this drug, but exclude the injectables. And then you have a code. Then you have a code list that excludes injectables for whatever reason. It's just an example. So let's go back to our app and try a little searching on diabetes. So we'll do a couple things. We'll do semaglutide as sort of our target population. So we have semaglutide. Search for that. This is the search results view. So it's saying everything that it found that has that text in it and it's showing you what vocabulary it came from, what class it came from. These are columns as well. So you can say, I just want to see the RX norms. So it's only showing you 62, but if I turn that off, it's 318. So I can say I only want to see RX norm, or let's say I only want to see the drug, well, maybe these ingredients. So the red ones are the non-standard concepts coming from these vocabularies, but the standard one that we like is coming from RX norm as our standard vocabulary. We can see what type of branded forms we have. Looks like we have oral tablets, a pen injector, auto injector. All these things are just showing you how to filter out the, this left nav is how to filter the results into some type of filter that you want. You can also do a secondary text filter here. Like, yeah, this filter looks across all the columns. So if I want the ATC stuff, I can just type ATC here and it'll show me that. Okay, so from here, you choose what you want to look at by clicking on it, and that'll kick you over to the concept details view. The concept details has several tabs here. Details tab shows you information about like metadata about the concept. Related concepts tells you like all the different concept relationships to this concept. And I guess I should have probably clicked this earlier. There we go. Okay, it didn't take too long. Sometimes this can be a lot if there's a lot of related concepts to something. As something to try on your own, if you ever search for pain, pain is a widely specified term in a lot of our concepts, and you'll have tons of hits if you type in just pain. But anyway, these are the related concepts. So we can see that the type of relationships, it's here's the standard to non-standard mapping. So these all are some sort of a, relationship descendant, sorry. So here's the ancestors of semaglutide. You can see it rolls up to ATC classes, and I guess that's it. I thought it might roll up to ETCs, but I guess I just have the ATC vocabulary here. So you can see how it rolls up. We can also see how it rolls down. That's, let's see, descendants. Let's see. As a descendant, yep. So here's all the different descendants. So semaglutide was the ingredient, but then we have the clinical drug composition, dose group, the branded drug, the clinical drug, et cetera, et cetera. So you can see this hierarchy, right? But the most interesting, to my mind, one is when you're looking at a concept and you just want to see what an immediate parent is or what its descendants are. This screen, and I am going to just lower this a little bit. Hopefully it's not too small, but so in the middle here, we have what the concept you're looking at. The parent it's a GLP-1, which we saw from the protocol. We're talking about GLP-1s as comparators. So this is the ATC4 class here. And then immediately underneath the ingredient level of this concept, there's all the things I talked about, where you have these branded drugs, clinical drugs, compositions, things like that. So if I want to add this to my code list, because I like this code, then I check the box and I say I want this, and I do like all the descendants. So I'm going to say I want the descendants, and I'm going to add to a new concept set. You'll notice on the right-hand side here, we now have a little red icon next to concept sets. It's saying I have an unsaved concept set now. So clicking over here, we can see this is it. We'll just call this semaglutide for demo. And I can save it. And hopefully this will be pretty quick. Okay, so because I chose descendants, you can see that the included concepts is 159 descendant concepts being included. Just real quick, I'm going to just show you that if I turn this off, this refreshes and it's going to show me one included concept. Why? Because I put one concept in my concept set that I didn't ask for descendants of, so it's just giving me the one. The included concepts is itself the concept that I added to my concept set. So this is the one included concept. But if I want the descendants in this case, because I'd like all the different flavors of this drug that are in the hierarchy, so that gives us this 159. If you recall from the view we just saw on the search screen, it had all the different compositions to it. If I want to exclude, say, one type of dose form, like I would like to get rid of the pen injector, how about everything except oral? So I'm just going to get rid of these guys. So what I'll say is I'm selecting these guys and I want to add these 3 elements as exclusions with their descendants to the concept set. So if I do that, I now have 61 included concepts. So as you can see, I have these guys excluded. So now, interestingly, apparently these guys are not falling underneath that hierarchy. So when I look at my included concepts, it looks like there's still some things in here, but actually it says oral product here. So this is actually pretty good, assuming that all these are orals. Yeah, see that a lot of these are oral tablets. So something's interesting happening with this injectable product. If I said the injectable solution, like maybe it's not technically injectable solution. So what we can do is I can click on this injectable product and see where is it in the hierarchy, because I thought it would be captured here. So if I take a look at the hierarchy, it is under semaglutide injectable product, but you saw the ones that we excluded. It was not one of the ones that we excluded. See, so that's why this wasn't captured. Apparently, this isn't under a. If I go to my concept set again, it's not underneath pen injector. It's not an injectable solution. It's not an auto injector. It's basically classified underneath an injectable product. So if I want to figure out how do I get rid of this thing, I go to my injectable product thing. I go to I can actually right here if I don't want it. So why don't I do it this way? I don't want that guy. So I'm going to check it and tell it to exclude from here. So I still don't want this guy. So I check him. I say exclude and his descendants at the concept set. And now we have less. And if I just want to get a little bit there. So now, right now, this is looking kind of like the type of drugs I want in this code list. Going to focus on oral things that don't have any injectable stuff in it. So this was kind of off the cuff. I planned on another type of example, but I thought this was a good one. What I like to do is do one more example using type 2 diabetes. Occasionally, and I'm not going to save this, it's fine. Occasionally, you'll be given a code. So in the case of diabetes, it's E11.1. I think it's E11.1. Let's find out. This might actually match too many. Sorry, I had my little note taker here for E11.1. Should have given me diabetes.
Chris, while you're waiting, Evelyn, you had your hand up. Is your question resolved, or did you just give up?
No, I gave up. No, I just sorry,
yeah.
sort of semi-basic question. But what's the difference between ID and code? Because I don't get the difference, and I'm struggling with that.
Oh no, Evelyn, you should do your homework.
Sorry.
No,
Chris,
there's no bad questions here. So a code is the sort of unique identifier within a vocabulary. So in this case, it finally worked. I don't know why that paste didn't work last time, but I searched for E11.1. And this is a great kind of example, I think, where in this vocabulary for this procedure, its code is E11.1. In ICD-10, though, if I go to ICD-10, here's the 11.1s for this. So an ID is a universally unique number for a particular vocabulary element concept. So the IDs are universally unique. Codes, on the other hand, you could potentially have a conflict between vocabularies. Does that make sense?
Yes, that's perfect. Thank you so much. That makes a lot more sense. I couldn't find an answer. Yeah. Sorry.
Yeah,
Thank you.
Yeah, no worries. Okay, so so we've searched for this, and here is this. So very interesting, right? I mean, well, this is coming from 2 different vocabularies, so they'll hopefully tell you this is the code from which vocabulary it is. So we'll just quickly click on that. Okay, great. So this is diabetes mellitus with ketoacidosis. Okay. So it's a non-standard concept. Remember, we don't use non-standard concepts in general. You can, but we prefer not to. So I'm going to look for what is this? What does this map to? And it's a little bit easier to see here because this is showing you a bunch of non-standard concepts, and then this is showing you this. And if we click down to the non-standard to standard map, this is an interesting case, which is this concept, type 2 diabetes with ketoacidosis, is actually telling you two things. And so there's two concepts that are associated to this source code. So when this gets ETL'd over into your data, you're going to have two records in your condition table. It's going to say you have this type 2 diabetes diagnosis and this ketoacidosis diagnosis with diabetes, I should say, because they're two different things. Diabetes is like that insulin resistance thing, and this ketoacidosis is like some disorder consequence as a result of it. Sorry, I'm not that clinical on diabetes. I should have ChatGPT'd that, but you get the idea that this source code is a combo, and the vocabulary that we standardize on really likes to focus on one clinical idea at a time in general, but there could be some combo concepts. But this lets us say, if I just want to find people with ketoacidosis, I can just look for the code for ketoacidosis, and then if I just want separately type 2, like I will find this person if I just look for the type 2. So for this indication that we're trying to build in our application, in our study, we're looking for type 2 codes. So I'm going to add this to a concept set. I'm going to include descendants. I'm going to, again, add to a new concept set. And we have these concepts. Now, if I wanted, I'm going to show more of this. This was the included source codes is telling you, based on which concepts are in your concept set, these are the source codes that map over to it. This is a great way to understand, like, if you're in the world of ICD-10 codes, you can look through your ICD-10 codes here, which is here, and you can see that we're including stuff that involves like pre-existing in pregnancy and things like that, probably something we didn't mean to intend to include. So what that means is that the question is which one of these included concepts brought in that source code that we didn't mean to. And so if we don't like the pregnancy one, we can click on the source code. It'll flip us over to this. We can take a look at our related concepts. And we'll see this pre-existing type 2 diabetes in pregnancy. Okay, let's just say I didn't mean to bring that in. I don't want that in. So we'll select it. We'll exclude it and its descendants, back to the concept set. And now this is reloading, and now we should have a fewer number here. And if we take a look at our included source codes, we shouldn't see that ICD-10 anymore because I excluded the concept that mapped over to it. Let's see. Ooh, I want to CM, right. So see how the in pregnancy is gone. Now I know I blew through that very quickly. Sorry, this is where the deep dive, right, gets to run long. But the point is that the Atlas tool will let you see, using a concept with descendants, what are my source codes? That's the included source code stuff. And then you can say, oh, I didn't want the source code. I didn't mean that. What is the standard concept that brought that over? You get rid of that standard concept, and now the source code goes away because the standard concept won't bring it in anymore. So looking at how the flow of the application goes, you start with your expression. This expression determines what kind of codes you're going to bring in. That's this. These are the codes that came from your concept set expression. Then moving to the right, these are the source codes that would map over to those concepts so that you can just understand what exactly am I talking about from a source code perspective. So these three tabs work together very closely. The other thing I'd like to just touch in on is this recommended concept. So looking at the included concepts here, which is all very type 2 diabetes diagnoses, the recommended option comes from a system called Phoebe. And Phoebe basically is a concept recommender thing that will look at your included source code, look at your included concepts, meaning what are the concepts in the code list, and it'll suggest things based on patient data and other type of synonym text matching. It'll suggest maybe you actually meant these concepts too. The three main ways of doing it is lexical and via source. So what these two I'm not going to focus too much on, because basically it's just looking at synonyms. Like there's other synonyms to these concepts that you might actually want to include. But the one that's very interesting in my mind is what's called patient context. What patient context recommendations mean is that they did this analysis on real world data, and they noticed that there are other codes associated with this concept of type 2 diabetes, or I should say these 16 concepts. There's a bunch of concepts that are tightly correlated to these 16, and it's going to suggest here are other ones that you might want. So what we saw before is that we include diagnoses of type 2 diabetes in our code list, but look, there's complications. That's potential code that you might want to incorporate into your code list. Disorders due to diabetes. Maybe that means you have diabetes. Like you could interpret that to mean like you are a person with diabetes, so because you have a disorder due to the diabetes. Hyperlipidemia is probably not diabetes, but something that is suggested, like maybe you actually want to look at this. It also shows type 1 and things like that. So, so interesting, this type 2 diabetes uncontrolled, which is an interesting one. Let's take a look at where this comes from in the vocabulary. So in the hierarchy, this is underneath diabetic poor control. Okay, so is diabetic poor control underneath the type 2 diabetes hierarchy? So we're going to look up one more level, and it's no, it's basically just the finding. So we go to diabetic poor control. Is that something that we want to include? Well, it talks about type 1 and type 2, so we probably just don't want to include all of diabetic poor control. We probably want the diabetes type 2 poorly controlled. So how about this guy and this guy? So poorly controlled type 2 and type 2 diabetes uncontrolled. We'll include those as descendants and add those to my concept set. Okay, again, I could go over for many more hours, and really getting the right codes for your study is a lion's share of the study design. So I'm going to stop here talking about how to navigate through the vocabulary and what the different screens are, because we could go into very nuanced what is diabetes, what should be used in the study. But I hope I conveyed the idea of how to use the tool to basically explore the relationships in codes and filter and add and remove codes from your concept set. So in the end, we could say that this is my diabetes, my type 2 diabetes, code list. Like this could very well be my code list, and it includes 17 concepts, which is these right here. So when we have them, I guess the other thing I want to point out that I just remembered is I want to show you this row count stuff. The row counts are coming from the Achilles analysis. So when we do things, we actually do a big counting sum of all the different concepts that you find in your data, and we make these row count statistics. We use this to basically guide us into what are the things that we should fight about. For example, I said, oh, look, we recommended a poorly controlled type 2 diabetes. Maybe we should use that. Well, when we look at the data, there are no records that have this coded into it, so it's not worth arguing about potentially. We actually produce a row count for a big network study that we did that you could load into your environment that gives you counts not just of your data source, but of all data sources that basically we've done an analysis on as an Odyssey study. And this will basically say, even if it's not in your data source, it might be in the network. So maybe you do want to think about these codes. But this is, I think this one did come from the network, because I'm looking at some of these row counts and they didn't come from this data set, but this is like 1.2 billion descendant records, right? So in all 1.2 billion descendant records of type 2 diabetes, we didn't actually see anybody coded as poorly controlled type 2 diabetes. So we're going to ignore it. We essentially not have to worry about this. But I wanted to just call this element of the UI out too, this DRC counts. So RC is row count, DRC is descendant row count, meaning there are descendants of this concept that have records counts as part of them. And then the PC DRC is the same thing, but with persons counts. So instead of counting records in the data, they're calling distinct people descendant, and then people from the record, from the concept itself versus descendant concepts. That's what the DPC is, descendant person count. Okay, so getting 10 minutes left of my presentation here. Losing a little bit of time due to technical issues. You guys can still see me, right? Okay, great. Okay, so in the end, I also want to just call out a couple of other functions that might be interesting. I'm going to close this without saving. There is a tagging system inside of Atlas that you can create tags. For this demo, I actually tagged a bunch of the things I'm going to use for this demo as APAC. And I created a secondary diabetes code list, warfarin, semaglutide, a couple other things. So I tagged these here. So there's this notion of creating tags so that you can organize your code lists and cohort definitions in the tool. I think from a demo perspective, I think I've covered pretty much the depth that I wanted to as far as searching and creating code lists. I'll pause right now. Anything that anybody wants me to ask before I move on to cohort definitions? I know it's a fire hose of information. I know, but moving on then. At this point, we have a nice set of code lists that we're going to use in our study. So I didn't actually go through the protocol too much of the study, but we did talk about what the T's and the C's and the O's are. Inside this design, it actually talks about what the target population is. So we're doing a comparative cohort study. So we want a new user cohort study. So we're going to create a cohort about new users of semaglutide. And they're saying as second line treatment with prior type 2 diabetes. What do they mean by second line treatment? They're saying has a prior metformin. So when we take a look at the rules for this cohort definition, we're going to enter at the exposure of semaglutide, but you have to be 18 years old. You have to be type 2. You have to have a type 2 diagnosis. You can't have a type 1 diagnosis, and we don't want to see anybody with secondary diabetes mellitus anytime prior to the exposure. So what I'm going to do is real quick, just try to show you how cohort building works with this specification, and just kind of see if I can do this real quick on the fly. That won't confuse you too much. So going into the tool, we're going to start a new cohort definition. As soon as I click on it correctly. Okay. So this is going to be our new user. Okay. So just to orient yourself, we're looking at a blank cohort definition here. I'll just save it real quick, just to save it. Green. Notice how it's green now, saying you have no unsaved changes. So the way you define cohort definitions is you say what observational data will enter you into the cohort. You can apply rules around including people in the cohort at that time. So yeah, you got this semaglutide exposure, but were you old enough? Did you have the right comorbidities? Did you not have other medication at the time? All these rules you would put in your inclusion criteria. So for starters, we're going to say that we want to we're using semaglutide. So we're going to enter at not a device, we're going to enter at a drug. And we're going to import the concept set from our list of pre-built code lists. I tagged these for APAC, so I'm going to use the APAC ones that I created. So I want semaglutide, so it's going to import that. We can quickly see what's in it. It's just basically the semaglutide ingredient with its descendants. For new user cohort, we want to have at least 365 days of prior observation. That means from the time of this exposure, I want to see an observation period older than a year ago. If it's less than a year, then it's not continuous. You don't have 365 days continuous observation. I also want to say that this is the first exposure. So I'm going to look for just the first exposure with the 365 days prior. And earliest event is a little bit redundant here because I'm saying it's the first, only consider the first exposure, but this isn't an optional thing. You say, do you want the earliest or all events or latest? But for this, we'll just limit it to the earliest. And then we want to include some inclusion criteria. So we'll start with the indicated population. Let's say has indication. Plus age. All right. So getting back to this protocol, we're saying you have to be greater than 18 years old. So we're going to add a demographic of age greater than or equal to 18. So did you see how I did that? I added some criteria to this. This is a group, by the way. It's saying I have to have all of the criteria, which I'm going to build here. So age is one element. The second element of this is type 2. You have to have some type 2 anytime before. So if we find a type 2 anytime before, so we're going to add a condition occurrence of, we haven't imported the type 2 codes yet, so we're going to import it. Filter into this. So we have our type 2 codes here. So when we say it should be anytime prior, it means that this diagnosis has to be anytime before the exposure date up to and including the index date, we'll just say. So between all days before and 0 days after. So you see that creates this little window of time that I'm looking for occurrences of this code. And I'm saying I have to have at least one record of this code, something from this code list, anytime prior to this drug exposure. And I'm just going to go through a couple more examples just to show you the example of you must have this must exist. And there's another case where you can have something else. So in this case, we're saying you do not have type 1 diabetes, or we do not see a code of type 1. So I'm going to add another condition occurrence criteria. I'm going to say it has to have exactly 0 of importing the type 1 codes. And again, is that recently or for all time? Let's find out. No condition of type 1 anytime before or on the entry date. So no problem. So we're going to say exactly 0 all days before to 0 days after that. So this group right here is 3 things. Age, you do have a type 2 and you don't have a type 1. That's what this group is saying. And I said having all here. I'll just show you the other choice here, which is an any. We're not doing that here, but I just want to show it as far as like just to give you some context. If I said any of these could be true, you could be 18, or you have this condition, or you have this drug. You can use this to say these are the 3 criteria, and you can have any of these. The other one in here is at least. So you can actually say, and you see these a lot in protocols where they say you are like I don't have a good example of like a multi thing, but if you have 4 of these 6 things, then you're considered in the state. So you could have 6 of these criteria, and then you could say you have to have at least, and it's always saying 2 because I have 2 in here. But if I had like, you know, a drug and a procedure, right? So I have like, and I'm going to remove this real quick. So let's say I have condition, drug, procedure. I can say I have to have at least 2 of the 4 of these. If I have at least 2 of these things, this is included. I can also say I don't want to have too serious of a problem. So I can also say you can have at most 2, meaning if you have 3 of these, you're out because you can only have up to 2. After you go too high in the scale, so to speak, you're out. So again, this isn't relevant to this particular study, but I wanted to just show you the function. I'm not going to actually save this because I'm just going to go to the pre-canned, pre-baked one in a second. But before moving on, I basically talked about entry events and the inclusions. And there is one more thing I'd like to go to. I know I'm at the end of my time here, but how much further do you guys want me to go? Do you have another 5-10 minutes? I can kind of wrap this all up pretty nicely. Okay.
Yeah, I think let's go.
So,
yeah.
Sure. Any questions about just what I talked about as far as entry and inclusion? Kind of okay? Okay. Best way to learn is to play with it, but entry and inclusions. You can also add multiple inclusion rules, which we'll talk about later. So, you know, in this study, in this particular thing, we're saying like, this is like just the base inclusion to be an indicated. So you have to be the right age and you have to have the indication. Like that's the first inclusion. Then you have to have this. Another rule is prior metformin. Another one is no GPL1s, no prior DPP4s, no prior SGLT2s. There's all these rules about semaglutide that we want to have. So without further ado, instead of recreating that, which would take a few clicks, I'm going to just close this note it says you have not saved changes. Would you like to continue? If I say okay, like I did not save my changes, but that's okay. So what I want to do is actually pull up the actual study specifics, new user semaglutide cohort, showing you exactly what's in it. So we enter the event on the semaglutide. Here is our indicated population, which is pretty much what I just did before. Now here we're saying we want to have metformin. Now they define metformin in two things, and notice the any here. If either of these is true, you're in. The first one is that you had a drug era that extended longer than 90 days that started before 90 days ago. So that's just the rule they came up with, of saying like you have a 90-day exposure to at least a 90 days exposure to metformin, or we have 3 distinct drug dispensings of metformin in any time prior. So that's what this is what metformin, prior metformin use is. You have a 90-day thing, or you got 3 dispensings. That's how they defined it. The second rule is no prior GLP-1, so it's an exactly 0 of this set of drugs. No DPP-4s, 0 occurrences of this drug, et cetera, et cetera, et cetera. All these things are talking about to see that we're talking about the right person. This last one's interesting. No prior insulin use might indicate like a misclassification to type 1, or maybe a severity of type 2. Like we don't want insulin use in our population, so we're going to exclude prior insulin use from that. And notice this is an interesting one in the sense that it's actually looking only at recent insulin. So prior 30 days is saying you have to have 0. Okay, and the other thing I just want to call out here is so we've defined how you get into the cohort by entering and then qualifying the entry events with inclusion rules. If you pass that gatekeeper, you're in, but now the question is how long are you in for? So in this particular cohort definition, we are saying you're in for the duration of a continuous exposure to the drug. So you have choices here to either say you're in until the end of your observation period, you're in until the continuous exposure, or you're in for a fixed number of days. Like let's say once you're in, we'll let you stay in for 60 days. And as long as you have something else keeping you within that 60 days, you'll be continuously in the cohort. So in this study, we just want continuous exposure of that first exposure. So we choose N of continuous drug exposure. We choose the semaglutide code. And we say, okay, if there's a gap within 30 days, we're going to consider that as continuing the exposure. So this type of cohort exit called continuous exposure is based on a drug exposure that is within 30 days. As long as you keep seeing the drug within 30 days, we're going to extend your cohort duration to be longer and longer and longer and longer until we don't have that exposure anymore, and then you're stopping. So that's pretty much the anatomy of a cohort definition: entry, inclusion, and exit. If you use that, you're good to go. Another thing, we aren't using it here, but another thing is that you can use other observational data to censor. So let's say we're talking about type 2 diabetes or semaglutide or something. Let's say that if you receive an amputation, you're out of the cohort. Like we don't want to see you anymore if you have an amputation. So we could create a code list of what amputations are and say that we will censor your cohort episode at the time of an amputation, for example. It could be anything. We could say if you go to the emergency room, you're done. So these censoring events are basically also another way to specify how you exit a cohort. Okay, all right, that's a little advanced feature. What I'd like to show you, and I know we're running late, is I actually generated this on my sample. I found 395 people in my database that satisfied all these criteria. And you might ask yourself, like, how did they solve the criteria, or how do they satisfy the criteria? So inside of the generation tab, once you generate, you can actually see how the inclusion rules cause certain people to be matched or pass or fail these rules. So this is a visualization on the left side here. This table is showing you each individual one. Like these look really good. How did we have 395 people left when we had 4,400 people coming in? And the reason is that lots of different people missed one rule. So this light green right here is showing you all the different groups of people that missed exactly one. So this group missed the one that's red. So these people did have prior insulin. These people did have an SLGT2. These people did have the GLP-1. But what's cool about this visualization is that if you go into the yellows, they'll show you combos. These people weren't in the indicated population, maybe they were too young, and they didn't have prior metformin. These people had a prior SGLT2 and had prior insulin. You can see how this is like all the combos here. But you're only in the cohort, you only get your match 395 by matching all the criteria. This is just showing you how the impact of the rules kind of overlap with each other. Okay, so fun little report there. Okay, so to kind of fast forward a bit, because I would like to just cover one last thing in the last 5 minutes, and that's some of the characterization stuff. Because you have your cohort and you know you have people, but you want to do something with it. So the Atlas tool lets you kind of do characterization steps. So I made a characterization that talks about semaglutide and its comparators. So I want to talk about two things here. One is I created a characterization design that has the 3 comparators, so semaglutide, dulaglutide, and extenditide. These are all ones in the GLP-1s. And I created a characterization that is going to look at drug group and condition era long-term, meaning what was happening in this population in the last year. I didn't use any other special subgroup analysis, which would be a deeper dive if we wanted to talk about that. So I executed it, and I have, I can hear my fan again. You guys still okay with me? Thumbs up? All right, great. So let me just show you this report. I ran this report, and what this is showing us is this is showing across all the different covariates, these are called covariates, in the population. So drugs used in diabetes, but we also have other things. Let's look at, this is showing drugs and conditions together, but let's actually just look at drugs. So these are the drugs. So metformin is very high as a prior. And then let's look at conditions. So what are the conditions? So type 2 diabetes without complication. Note, by the way, that these are individual concepts. These aren't grouped together in any way. So you'll see that why isn't this 100%? Because this was diabetes without complication, but there's another group of people that had type 2 diabetes in general. So you see how this is 81% here, this is 46% here. These are not mutually exclusive codes. Like most likely 100% of the people had some kind of the type 2 diabetes codes, but it was divided across all these different types of type 2 diabetes. So I type here, right? So we have all these different things that could have it. So that's just one of the things that, this might be a subtle point, but what you're seeing here is the prevalence of the codes that were found relative to your index date. It's not grouping it together. But let me show you how to group things together, because we have not only type 2 diabetes, but I looked ahead and there's a lot of different codes around pain, lower back pain, chest pain, neck pain, all these different pains, right? But if we just want to say like, well, yeah, what's the proportion of people that have pain? I made what's called a custom feature. And before I jump over to the custom feature, let me go back to the design real quick. I know I'm glossing over stuff, but to create your characterization, you say what populations you want to characterize and what analyses you want to apply to them. So when I clicked here, I'm just going to show you the presets. There's tons of these visits or procedures or observation, drugs, measurements, etc. You can get all these different type of codes that you can look in your report. And that's great. That gives you the underlying like individual coding that the person has. But you can also create, using concept sets, you can use a custom feature, and I have this one called general pain. And inside general pain, this is going to look very familiar to you because we're going to use the same concepts as we have in cohort building with this feature. So if you guys recognize this, I'm making 2 features in this analysis. I'm making one called short-term pain and one called long-term pain. And the short-term pain is saying I have to have at least one condition occurrence of my general pain codes, which is, I have a lot of them, but I have all these different type of pains in here. And I want to see, in short term, I want to see a pain code in the last 30 days of index. And in long-term pain, I say I want to see a pain code in 365 days prior. So any type of these pain codes is going to just be called long-term pain in my report. And the short-term ones that I find in short-term are going to be called short-term pain. So what does this look like? So I'm going to close this custom feature. I'm going to go into my, versus these two tabs, I was looking at features. Now I'm looking at my characterization designs. I made this V2 characterization, which is the same thing as V1, except same target populations, same feature analyses, long drug group, long-term, condition error long-term, but now I have my general pain custom features, which has those short-term, long-term pains. So when I generated that, let me just show you what this looks like. Okay, so I'm just going to jump right to the chase here. So now we have another table here. So remember, I asked for the drug group long-term, the condition error long-term. So we just saw that. That didn't change. See how these type 2s are not exactly 100%. But now in my long-term group, 65% have some type of pain code in the last year, and 27% have some type of pain code, same code list, but different time window. 27% had something reported short-term within the last 30 days. And that's cool. So that's kind of a nice way of kind of grouping codes together and getting this report. Easier than, say, going through pain here and saying like, okay, like, yeah, you can't add up all these numbers because people with lower back pain may also have neck pain. Like, you don't know how they split out. But this actually groups it all together and counts one person only one at a time. So 257 people, 65% of the people had some type of pain code in that long term. Pretty cool, right?
Mm-hmm.
Okay, I know I'm 15 minutes over. Does anybody want me to maybe go on 5 more minutes and I'll show you 2 more types of characterization? All right, okay. And like, I'm punishing myself here because like I had that technical problem, so I feel real bad about that. Okay, so I'm gonna go into incidence rates and I'm gonna show you the design I made for incidence rates. And I'll just show you real quick how it works. You click new analysis, you say I want some targets, so I'm gonna filter to my APAC, and I basically click on my new user semaglutide, new user this one, new user this one. And if I just close this, it added the 3 here, and then I add my outcomes, which I'm looking for the NAON and the DR, the diabetic retinopathy here. So that added it here. So when I create my incidence rates, I have to say, what is my target population and what are the outcomes I'm looking for? And then you have to say what the time at risk is. And it defaults to the start date and the end date of your cohort. As you recall, we created these new user cohorts to be the first exposure continuously to the end. So the time at risk I want to say is going to be the time you were treated. So I'm just using the cohort start date and the cohort end date because that's the time you were treated. However, I could say I want to go from the start date to the start date plus 365 days, saying regardless of their treatment status, like on treatment or off treatment, I just want to know what happens to this population after a year. They initiated their treatment after the year, give me that rate. But that's what time at risk means. Time at risk is what is the time window based on your cohort that you want to look for the outcomes. Okay, so that's how you build a design. So now I'm going to show you one that I actually built. And it's going to be this guy. Okay, so you click on the generation tab, you click generate, and it will show you the result. Now, although you can export the analysis to CSV and see everything together, this UI is going to seem strange to you, but I'm going to explain, I'm going to justify why we did what we did here. We don't show you side by side any of the target populations together. We did this consciously. This may be annoying because if I want to see, okay, this is semaglutide, how do I see the other one? I have to kind of click one at a time and see it one at a time. The reason why we do that is that we are trying to discourage looking at a rate of semaglutide next to a rate of this guy, right? One of these guys actually has a code. All right, see these 4 cases. So this T with this O has 4 cases, and I can actually show you, like you can see a report here that actually shows you this case breakdown. But sorry, I took a side tack. The reason why we make you do this is that we don't want you to say, oh look, there's less cases in this population than this cases. If we put it all in one table, you'd be encouraged to compare these things, but it is not epidemiologically best practice or even appropriate to look at two unadjusted incidence rates and compare them to each other. So we make it hard for you to do that. But if you export the analysis as a CSV, we're going to show you everything in one spreadsheet. So foiled again. The export to CSV came in later. So when we talk about Atlas 3.0, and I'll give you a brief update, we're going to be updating a lot of these reports to be more user-friendly based on user feedback. We're just going to hope that people don't use these comparisons together, and we'll just give you a table with everything in it at once. But anyway, this is how this one works. I wanted to show you one other one real quick. So this guy, let's see. Yes. So in this one, we're looking at IBD with this herpes zoster is the outcome of interest. This was interesting because I actually created sort of like the stratify criteria. Again, it looks exactly like an inclusion rule. We're going to group these incidence rates by people who are less than 18, less than 64, and female. And just to show you what this works like, this actually has cases, so it's actually kind of cool. This is going to be a much more interesting thing. What this heat map is showing you is that I'm showing you each individual strata breakdown by there was one person that was less than 18, there was 64 people, there was 105 that was less than 64. By the way, this 105 does include the 18. And then there's 153 that were just females across all the age groups. What I can do is I can hover over these boxes, just like I did in that inclusion rule on the cohort definitions, and whichever one is red says that it wasn't this. So this group right here with this rate represents the people that are women and older than 18 but less than 64. So that's this group. And here is the one same thing, except now they're not women. So this is the females, this is the males. So you can see that it looks like there is a higher rate within the female demographic of this than the males in this particular age group. See what I did there? I know I'm spending 5 seconds on this just to show you something cool, but play around with creating some strata, and this thing will show you all the different combinations. So this red box, which is seemingly in this scale I made down here, is showing you the least incidence to the highest incidence. This red box is in that highest group. What is the highest group? It is the one that's not less than 18, not age 64. That means that these people are greater than 64 years old and they are female. So the highest incidence of the strata is in the elderly female population. But where are the men in this? We could go around. So this is the female. Here's the men. This is the box that represent not female, not less than 64, not less than 18. So that means these are the men who are greater than 64. So this is the rate of that group. So by creating all these strata, you can get all these little subpopulations of that. All right, so there's our incidence rates. Have fun with that. One more, and then I promise we'll get out of here. Okay, and that's pathways. Now, as you saw, I did the analysis. I created cohorts for the T's and C's of that study I wanted to replicate with you guys, just from a design perspective. And you saw there was one population that had 4 cases, and then another population had nothing at all. So they're not very good size population to do a pathway, but I wanted to show you a pathway. So I dug up one of our own studies we did internally of just a characterization. And this one is a study that's trying to look at the time of your diagnosis with ischemic stroke, what are some of the medications you might go on to take? So we are starting with the indexing on ischemic stroke. I'd have to look at this real quick. I guess I can real quick. I'll just pop over to it. What does it mean? Ischemic stroke is these codes with an inpatient ER. And when do you leave? You leave 30 days later. Interesting. Okay. So this is a very short-term cohort where you're finding these people that qualify, but then they're only in the cohort for 30 days. So when I go into my pathway, I'm going to be looking for what medications use happen within 30 days after you have your stroke. So interesting question, interesting characterization question. So let's take a look what we got. Going to executions. This is my sample I generated. I can view the latest result. And according to this, in the 30 days after the stroke, most people had this P2Y12 inhibitor, whatever that means, followed by either direct oral DOAC or aspirin. And that's basically the 2 here kind of thing. So you see how that works? So this is the first line therapy and kind of second line. I wouldn't call it a first line, second line therapy. It's just the sequence that thing we saw in the data. This is all a summary statistic. Other people started on aspirin. Other people started on DOAC. Other people had a combo start of aspirin plus this. So the pathway analysis is kind of showing you what is the sequence of things across the population. It doesn't really tell you, and this is a possible enhancement in the future, it doesn't tell you time it took to go from one to the next. So we have 545 people that, well, let's go this. We have 8 people that went from the P2Y12, whatever, inhibitor use to DOAC. So we have 8 people that went. So among the 545, 8 went on to DOAC. But maybe 4 did it the next day and 4 of them did it 2 weeks later, right? We don't really have the breakdown of time it took to go to the switch. This thing is just showing you sequence of events. Could be informative, could be some interesting piece of information about like what the sequence of events are for people after their entry into the cohort. So to build this design, it's just a matter of saying what is your target population and what are the cohorts that would indicate an event that you want to see a sequence of in your pattern, in your pathway. So that was literally a 2-minute briefer on how pathways work. Okay, so there you go. I kind of hit all the topics I wanted to hit as far as like searching, looking at data sources, searching vocabularies, building your code lists, using those in your cohort definitions. And then what can you do with those? We have 3 flavors of incidents that you can do. Real briefly, I'll just talk about what's happening in 3.0. 3.0's Atlas 3.0 is really focusing on upgrading stuff. There's stuff that's 10 years old that's not even really supported anymore. So we're running on very old software. We're going to be spending a lot of our energy to that. We're also going to be removing obsolete code. So these things you see here, estimation, prediction, like these are no longer really up to date anymore. So these are going to go initially, but we can bring them back and use strategists later. So we're going to have tighter integration with strategists when we get into the Atlas 3.0 space. So the timeline for 3.0 is first, second quarter of 2026. So we have like 3 to 6 months to kind of just get all this conversion done. And then 4.0 is going to really have more significant user experience changes, as well as a technology shift as well. This web app is going to be written in that type of different technology because we're trying to get more modern day developers on our team. So a lot of people have been asking to use something more modern. So V4 is going to be sometime towards the end of 2026, hopefully. Okay, very sorry about the technical delay, and I'm happy to come back to any topic here at another meeting and like do a deeper drill through if you guys have a question, or you guys say you want to do a study and you just want to kind of have me on board to kind of just say how would I go about building it, you know, it's fine. But there is a lot of cool things that are like we just scratched the surface, and all these things that we build in Atlas is a standard practice to basically export that using R to build your strategist analyses off of like cohort definitions and concept sets that have been built in Atlas. So this is all done without any programming skill, but then you actually have somebody coming in and taking it and running it through code to get it into a strategist analysis. Cynthia, what's up?
Yeah, so at some point, a few of us may want to come and pick your brain on using Atlas to set up a self-controlled case series.
Sure.
Because I think there was a decision in this group to also include that in the GLP-1 acute liver injury protocol, if I'm correct.
For sure. Yep.
Yes. Yeah.
Yep.
Okay. Thanks.
Sounds good. Happy to help there.
Okay.
I really want to call attention again to that, and I'll send out these slides. So I'll just I'll download a copy and send it out through the email. But really want to call out that this is a very cool thing that I hadn't seen, but it's here. And this is where all our network studies are kind of being cataloged here. I'm gonna see if I can like reload this. Can you guys still see me and hear me okay?
Yep.
Just trying to reload. So this is dataodyssey.org/Odyssey studies. Cool. So this is showing like all the studies that have been like tried to go through the coordinating center, and it's like network studies. Somewhere in here, I might actually talk about who is doing it, but it has start and end dates. I guess I think these are, I don't know if these are completed or in progress, to be honest. And I love how that's all the way out here. Somebody has a very long title. Anyway. So this is the ones Patrick pointed me to, the one I tried to walk you through today, but there's all these studies going on. All I'm trying to say is there may be something that somebody is already trying to study in that space, and you can kind of go here and see maybe. And if not, you can always post it here or talk to somebody that gets this posted, and maybe you could get more people involved in your network study. But I'm absolutely happy to talk to you guys about, setting that up and talking about that. On the note of the self-control case series, I would like to call that out. In a self-control case series, you want those periods of on and off exposure, right? So in the new user cohort, we took the first exposure and stopped at the end of the first exposure, and that works great for comparative cohort analysis. But we can show you what a cohort definition looks like for a self-control case series, which is basically saying, I want to use all the drug exposures, regardless of prior observation. I just want to take every individual drug exposure and group them together by the 30-day window. So if you have a person that's been on, off for self-control case series, this is the cohort definition that you'd use for that study, because you're looking for the periods of time on treatment and off treatment. And that's sort of a precursor to your question about how to create a cohort for self-control case series. Happy to go into it more detail later. All right. Well, thank you again, you guys.
G1 has a question.
Oh,
Yep,
no,
go for it.
I don't really have a question. I just want to say thank you, Chris, for your time here. And you don't have to punish by yourself by being late or like past that time schedule. But so I was learning through like my trial and error by myself. So this lecture was really helpful. But I still got several questions, so I think I'm gonna email you and
Sure,
ask you several
absolutely.
questions. Yeah, thank you for your time.
Yeah, I should have in my slide. I'm going to add to my slide my email address, right? So
Oh,
that
yeah,
you guys
for
can
sure.
reach out. You know what
Yeah,
I'm saying?
sure.
So I'll just add it right here.
Yeah, thanks a lot, Chris. I think it's really very detailed. I think we all can see that we got a very detailed overview of Atlas,
Yeah.
and it was very helpful, to know the full features and what we can do with this powerful tool that we have at hand. Yeah. Okay. And
Absolutely.
yeah, definitely we'll invite you back. If there are more thematic-based sessions we can do with you in the future. All right. I know it's over time a bit, but yeah, thanks again to everyone for tuning in today. I hope you found the session.
Thank you, guys.
Thank you so
Thank you,
much.
Chris.
Thanks a lot, Chris.
Thank you.
Bye.
Talk to you soon.
Bye, everyone.
Bye.
Bye.
Bye.